Hi guys, in this short video I'm going to go through how you can use not the Kc constant but the Kc expression to predict changes in concentration of something in an equilibrium reaction. So we're going to look at two worked examples. The first one shows the reaction of hydrogen with iodine to produce hydrogen iodide. And the question says the equilibrium constant for this reaction is 36 at a temperature T. Now it doesn't say the temperature's changed, so we assume it's kept constant. If the temperature's kept constant, then it won't affect the equilibrium constant, so we can ignore that value. If the concentration of hydrogen is increased by a factor of 8, calculate the change in the concentration of Hi. So what we do first is we write our Kc expression, which is products over reactants raised to the power of the number of moles in the balanced equation. Then we rearrange in terms of the thing we want to calculate the change in concentration of, so that's Hi. So it's squared, so keep the square for now. And we rearrange, so Hi squared equals Kc, 36, times by the concentrations of the reactants. Now, if hydrogen is increased by a factor of 8, then according to this equation here, Hi squared will also increase by a factor of 8. Next thing we need to do is get rid of the squared, so we need to square root. So to get the effect of increasing hydrogen by a factor of 8 on Hi, what we do is we square root 8, and that comes out as 2.83. And that's our answer. So if we increase the concentration of hydrogen by 8, then the concentration of hydrogen iodide will increase by a factor of 2.83. And that's all there is to it. So the next worked example, we have nitrogen and hydrogen reacting together to make ammonia, otherwise known as the Haber process. So I've made a note here, note that Kc does not affect the concentration change. So the Kc value doesn't affect the concentration change, and neither does the temperature if it's held constant. So the question says Kc for this reaction is 12 at a specific temperature T. We assume that's constant, unless it says otherwise, which it doesn't. If the concentration of nitrogen is decreased by a factor of 5, calculate the change in concentration of ammonia. Okay, so this time it's talking about a decrease, so ammonia will also decrease, and we have to find out by how much. So we write our Kc expression, products over reactants raised to the number of moles in the balanced equation. We rearrange in terms of the thing we want to find the change in concentration of. In this case, it's the ammonia. We keep the squared at first. And there's our Kc, which is 12 in this case. Now, if nitrogen decreases by a factor of 5, then ammonia squared will decrease by a factor of 5. Next thing we want to do is drop that squared. So we square root the 5, and we end up with our value that ammonia will fall by. So when we decrease the concentration of nitrogen by a factor of 5, then ammonia will decrease by a factor of 2.24. I hope that was helpful. If it was, please like and subscribe. Thank you.